In a previous lesson, we learned about how to identify whether a relation is a function, and that if it is a function, it can be written using function notation. We're going to spend most of our time this semester in our study of college algebra looking at functions, families of functions, and solving equations. So in this lesson, I'm going to introduce 7 or 8 or 9, I'm not sure how many basic functions that we're going to explore in greater depth throughout the semester. If I were to make a t-table for each of these functions and plot several points, as many as I need to figure out what the basic shape would be, I would end up with these shapes. So we're going to look at each of these very quickly today in this lesson, and then we're going to use these basic shapes as we go through our lessons and look at each one in more detail throughout the semester. So the first one is y, or f of x, it could be either one, is equal to x. This is a very simple function in which whatever my input x is, that's the same as my output. And it gives me the basic graph that's this shape. And that is called the identity function. And it is the most basic shape of a linear function. We also have the graph of y equals the absolute value of x. And we see that that looks the same as the identity function, except as you know, if x is positive, y is positive. But if x is negative, y is still positive, and it gives us the shape that looks like that. Our next graph is y equals x squared. And we see that we have a shape that looks like this. That's called a parabola. So this is a quadratic, basic quadratic function. And we have y equals the square root of x. And this one is unusual in that in the real number world, which is what we're in when we're drawing graphs, because each of our number lines is a real number line, the x and the y-axis are real number lines, you cannot take the square root of a negative number. So this one starts at 0, 0, and then curves out to the right. Our next basic graph is y equals x cubed. This one was the square root. X cubed is a cubic function. And when I graph this one, I see that I have a similar upward shape that I had with the quadratic when x is positive, but because we're cubing, it goes up more steeply. But when you cube a negative number, you get a negative result. So when x is negative, y is also negative. And we have the cube root. Remember when we looked at the square root, there's no index written. There's no little number written in the radical. When there's no number written there, it's understood to be a 2. So square root means what number would I multiply by itself 2 times to get x? Here, a cube root, because I have a 3 as my index, excuse me, it means what number would I multiply by itself 3 times to get x? And I can multiply a negative number times itself 3 times and get a negative result. So my curve looks like this over here, a little shallower than the square root, but I also have the portion over here because I can take the cube root of a negative number. I also have the graph. This one is a cube root. I also have the graph 1 over x. If I were to take any number x and take 1 over x, it would give me its reciprocal. So this is called a reciprocal function. And we're also going to see later in the semester that it is the most basic rational function as well. And if I were to graph, to plot ordered pairs, I would see that I have a curve coming from negative infinity here. It does not exist at x equals 0, and then it starts up again over here. So these two curves together are the reciprocal function. And then later in the semester, towards the end of the semester, we're going to look at two functions. The exponential function, where a is some number that is positive and not equal to 1. And we'll have this basic shape. And if we have the logarithm base a, and again, a has to be positive and not equal to 1. And we're going to see that it looks like this. So, at this point, I don't expect you to know a lot about each of these functions other than its basic shape. That if I say x squared, you know it has a parabolic shape. If I say x cubed, you know it has this curved shape going up and down, and so on. We're not really going to look at the last three functions, 1 over x, a to the x, and logarithm base a of x. We're not going to use those shapes until much later in the semester. But I'd like you to memorize the first 6 graphs, what their shape is, and which graph they are, so that you could, if you were given a shape, say for instance you're given this shape, you would recognize immediately that's y equals x cubed, the cube root of x. If I gave you y equals x cubed, that you would know immediately that its graph has this shape, and so on. So spend some time looking at the graphs, maybe recreating them from memory, because we're going to use those basic shapes in our next lesson, which is transformations. Moving those shapes left and right, up and down, reflecting them, and stretching and shrinking them.